then it should give you a clear picture of the behavior of the parabola. Even without actually computing, if you say the parabola has 2 zeros, then the picture in your mind is the parabola will, Rosemary?
It will open upward.
Well, if it opens upwards, if it has 2 zeros, then what do the 2 zeros mean? When it opens upward, it will hit the x-axis how many times? 2 times, because there are 2 zeros. Okay? So for 2 zeros, you have something like that. Okay? Let's say we're only considering parabolas that open upwards. If there is 1 zero, okay, of course the 2 zeros are given over there, the points that lie on the x-axis. If there is only 1 zero, then that's a nice picture too, because the 0 is exactly
at the x-axis.
if it's on the x-axis. What is that point, Gerald? Maribeth, the vertex will lie on the x-axis, as so. And then, if your function has no zeros at all, then that should be a clear picture as well. When you graph, the parabola should not hit the x-axis, as so. Now, the nice thing about the partnership of the Cartesian coordinate system and your computation is this. You have a check and balance. If your solution says you have 2 zeros, and then you graph, and when you graph, you get something like this, you should know right away that something is wrong, because my graph did not hit the x-axis twice. So I might have drawn it incorrectly, or I might have computed incorrectly. The two should be consistent. That's analytic geometry for you. You use algebra partnered with geometry, thanks to René Descartes and the Cartesian coordinate system. Okay. Now, if you have a parabola like this, there is another very nice interpretation of the vertex. If it opens upwards, then it is a minimum point. If it opens downwards, then clearly that is a maximum point. Okay? And that is also achieved easily with the help of 0. How is that achieved? You know that the tangent line at the maximum or at the minimum is supposed to be horizontal. So at the minimum or maximum point, you know the tangent. Another way of saying horizontal using 0. The tangent has what slope? Our word for the day? 0. The tangent is horizontal, so the tangent has 0 slope. Okay? And if you're already at that point in your studies, then you can get this easily. Okay? The tangent slope is arrived at easily using a derivative. Okay? So what does it mean? If the slope of the derivative is 0, then you're hitting a maximum or a minimum. If you see this, there's a decrease, then you already know what's going to happen based on what you know from lines. If there is a decrease, then the slope over here must already be negative. There's a rise over here, the slope is positive. So you'd know also right away, based on your analytic geometry, if you have a point over here, then the value of the derivative, in other words, the slope of the tangent must be positive. So computationally, if you take this x, put it in your derivative, you should not get the negative, and neither should you get 0. Because the graph says, if you graphed correctly, the graph says it should be positive. So if you're going to analyze a quantity with this as its representation, you'd say that there is an increase in the quantity over here. there is a decrease in the quantity down here. If you refer to it as motion, there are many motion problems. Let's go to an application, just in case it's not so clear in this manner. If we go to motion, okay, if you start, there's zero velocity. But when velocity is greater than zero, sometimes that is referred to as movement to the right. And if it's negative, it's movement to the left. Right? Gravity is a rate of change. Acceleration is a derivative of velocity. Now, why is acceleration due to gravity given a negative value? Well, sorry, velocity is negative. But acceleration, of course, is increasing as it approaches the Earth. However, velocity for free fall downward is negative. Why? Because velocity, by definition, is, you remember the formula? Distance over time. That's a change in distance over time. And if it's negative, that means there is a decrease, just like slope. Distance is decreasing over time. So if something drops, velocity should be negative because it approaches the ground. Okay? So there are a lot of pictures given by being zero, being less than zero, being greater than zero. In a business situation, you'd be very happy if you get this graph for profit, because you are given a particular value so that profit is maximized. If you have something like this, you'd be very happy to know this if this were a cost function. Then you'd know where the minimum cost will lie. Okay? So whether you have motion or business, then this has very clear applications. Okay? Anything that you can refer to which increases, if you can graph it out in some sort of fashion, okay, whether like this or you go to cubic, quartic, quintic equations with higher degree, as long as the graph moves up, that's an increase. It starts moving down, that's a decrease. The slope over here, the slope is zero. Okay? The slope here, negative. Good, less than zero. The slope over here, positive. Okay? And then it moves up again. That means the slope here hits a zero and then it goes positive again. Now look at the pattern as well, class, as if you were on a real number line. Slope here is positive. You hit a zero before you can become negative. You cannot go from positive slope here and the negative slope without hitting a zero. Pictorially, why is that possible? If you're going to compute, you might not see the difference right away, but thanks to the coordinate system, you can see clearly that if you're going to move up, at some point you have to stop moving up before you start moving down. And that stop, that pause, is zero. Is where slope equals zero happens. So I go up, I climb, I hit a zero, I stop, and then I descend. Okay? I stop descending, I start ascending. Then I hit a zero, and then I go positive. Okay? And this is already an introduction to your studies later on when you even go to higher degree polynomials, and then you're asked to study not just minimum points, maximum points, but brace yourselves for inflection points, intervals of increase. You can see clearly here that over this interval on the x-axis, you can see a decrease, and then you're going to be asked to identify an interval here of increase, and you say there are two periods in the year that there is an increase, over here and over there. There is one period where there is a decrease, and it's all because of the slope, whether it is zero, less than zero, greater than. Okay? But so much for higher mathematics. This is already calculus. No? The story of calculus and zero is one whole story by itself. Meanwhile, we're playing with the role of zero over here, with the rest of the numbers, with the rest of the system. So maybe I should bring you back to the basic operations and the role that zero plays. first operation that comes to mind? Okay. If only we had addition to study alone. And none of these. However, thanks to 0, we have these. Okay. This is your addition table. You studied this not so long ago. And you see the importance of 0. What is the priority given to 0? When you list down the addends, 0 is always first. First column. First row. And what is the nice role played by 0? In addition, 0 is very humble. Why? Because any number added to 0 will be the number again. So it's as if 0 said, don't put me in the picture. Okay? That's why it's called the additive identity, because it doesn't change the number at all. Okay? 0 added to any number is the number again. Okay? It's the same for subtraction. 0 subtracted from any number is a number again. It effaces itself. It refuses to play a significant role, meaning of adding or subtracting from that given number. And if you read between the lines, subtraction is defined using addition. Subtraction is the addition of an inverse. Class, after zeros in polynomial functions, let's now go back to the basics. The role 0 plays in the basic operations. If you have any number and you add 0 to the number, it does not change the value of the number. So in addition, 0 plays a very humble role. N plus 0 is equal to n again. Now, if we subtract 0 at the same time from any number, again, it does not change the number. So you can say, okay, fine, 0 plays a humble role. If we look at subtraction again, A minus B is defined to be the addition to A of the additive inverse of B, or negative B. So that n minus 0 is equivalently n plus negative 0. Okay? Now, if it doesn't change anything, now look at this. It's the same as n plus 0, whether it's negative or positive 0. So here, we have the role played by 0 as being a bit more self-important. Here, you see that 0 and negative 0 have the same value. Because if you add 0, you get n. If you add negative 0, you still get n. So these two are the same. Again, 0 is its own additive inverse. So it starts to puff up now and become self-important. Okay? Now, what if any number is multiplied by 0? See? Now, I already didn't take any role in addition and subtraction. So now 0 asserts itself and say, okay, you try multiplying by me, you'll get me. So n times 0 is equal to 0. Okay? So now it's giving itself importance. No problem at all so far. Now 0 becomes problematic. It starts to act up. From being very well behaved to getting some airs, and then being downright problematic when n is divided by 0. It is not content to just get 0 back again. You multiply any number by 0. Again, look, 0 is the priority. It's up there. First row, first column. And the first column is all 0. The first row is all 0. 0 says, okay, this time it's all me. But in division now, I'll start giving you problems. Let's see, the wonder, that is 0. Okay. Not really problems, but something to you, or something for you to wonder. Okay? Something for you to wonder about, something for you to be in awe about. Why is that? Okay? Why can a number actually not be divided by 0? If you do this on your calculators, what is the result? Okay. It results in an E for error. That means you cannot get an answer. You divide by 0, you cannot get an answer. Why is that true? You can divide by any other number, just not 0. Okay? So 0 is referred to as a small quantity, as a small number, as if nothing is there. But any other quantity which is close to 0, you can divide by. For example, take n equals 100. I divide 100 by a small number, let's say 2. Okay, I get, okay. I divide it by a smaller number, 1. I get 100. Now look at this series, class. I divide this by 1/2. I divide 100 by 1/10, smaller and smaller. I divide 100 by 1/1000. I divide 100 by 1/1,000,000. So look at my divisors. My divisors are approaching 0. Smaller and smaller and smaller. And look at what happens upon division. 100 divided by 1/2. Okay. So this is halved. This remains. This is doubled. This increases 10 times. This increases 1,000 times. And this increases 1,000,000 times. Okay? See? So it seems that the closer this is to 0, this becomes very, very large. So coming back from division by a number closer to 0 gives you something very, very large. We can generalize and say if 100 is divided by a number where n approaches 0, gives us what result? 100 over n, the fraction is going to approach, okay, what term do we use for something very, very large? Something that continues to grow indefinitely? Infinity. Good. This goes to infinity. Okay. So now we see why we result in an error. Because infinity is not a definite value that the calculator can put in that screen. So it just says it goes indefinitely, it grows indefinitely if it's positive, it goes indefinitely to the left without end if you have a negative fraction. So this is a difficulty of dividing any number n by 0. Okay? But by any number n here, we may be thinking, does this fraction include 0? Okay? So here there's still 1 0. We make the assumption for now that n was not 0 initially. If n is anything which is not 0, you try dividing it by 0, you result in something very, very large or very, very small, enough to say that you cannot pinpoint that value. That value does not exist. That is an undefined value. Okay. However, we can take the case now when n itself is 0. So this is the big question. So what we are asking is 0 divided by 0 is what? Okay? You think if 1 0 present already gives you an error, then 2 zeros present might give you an even bigger error. Let's see. It's not called an error, but this is the bigger puzzle given by 2 zeros. Now let's take it from multiplication. If subtraction is the inverse of addition, division is the inverse of multiplication. So if we have any number times 0, taking it from the third equation here, class, 1 times 0 is 0. 2 times 0 is 0. 3 times 0 is 0. And indeed, for this set of numbers, down the line, n times 0 is 0. Now, I'll do the opposite. So we recall that if 2 times 3 is equal to 6, then 2 is 6 divided by 3, right? So using the same equivalence, this means that 1 is 0 divided by 0. 2 is 0 divided by 0. 3 is 0 divided by 0. Now, class, it's not just 1, it's not just 2, it's not just 3. It's any n. Therefore, 0 divided by 0, yes, is indeterminate. It's as if you want to ask, make up your mind. Are you 1, 2, 3, 4, n? What are you? Indeterminate. And that is one of the problems given to us by 0. There are many indeterminate forms. This is not the only one. You can think of 0 divided by 0, 0 as an exponent, 0 not just as a divisor, right? 0 as a base, and so on. Okay, class, we already learned that when you divide 0 by 0, you get something indeterminate. Now, with respect to indeterminate forms, there are several. Let me show you one more example of an indeterminate form very quickly, just to show you how 0 indeed causes a lot of, I'll say, wonder. Not problems, but wonder. Okay, 0 raised to 0. Why is this a source of wonder? Well, first, 0 raised to any exponent. Any exponent, positive, negative, any exponent. 0 raised to any exponent is equal to 0. Why? Because an exponent connotes multiplication. And again, multiplication by 0 results in 0. Now here, n is taken not to be 0. On the other hand, if we take the base to be non-zero and we raise it to 0, we know laws on exponents say we can prove that this is equal to 1. Okay? So just off the top of your heads, we're not even proving this yet. But just by looking at it in this manner, 0 as a base should give us 0. 0 as an exponent should give us 1. Now 0 as both base and exponent will give us 0, 1, 0, 1. Again, this is indeterminate. And in this manner, you can recognize other indeterminate forms once you are introduced to other partners of 0. Well, the main partner of 0, which is infinity. The discovery of 0 will always stand out as one of the greatest single achievements of man. Indeed, that is the wonder that is 0. So thank you, class. It was a wonder studying 0 with you this morning.
Thank you, ma'am.